Oh, hi there. Okay, so we're going to take a look at number 49. We are going to have to get it into vertex form, but it also is an inequality, which means at the end we're going to have to talk solid or dotted or shading. All right, first things first, this is not in vertex form. Not in vertex form, which means we have to start by completing the square. A lot of people notice that we have the 2. They want to pull the 2 out. Careful, don't do that right away. Your first step is making sure that your variables are separated from the 6. The reason you have to do that first is if you don't, you're going to pull the 2 out of everything. You don't want to do that, okay? Before we complete the square, the a value does have to be 1. So we'll pull that out first. All right, if I pull the 2 out, what's going to be left inside?
X squared minus 2x.
Nailed it.
Space plus 6.
Notice we did not pull the 2 out of the 6.
Wrong space.
All right, from here, let's fill in the blank. What would fill in my blank here to complete the square? It's half of b squared. So 1. Everybody good on 1? Question of the day, though. What goes there? What would go back here then?
He's going to multiply.
Yeah. Come on. Come on.
6 times 1.
What? No. Now remember, the rule was however much you manipulated the front, you do the opposite to the back. Now we put a 1 in here, but that quantity is being multiplied by 2. So how much do we really change the front by?
2.
So what do I have to do the back?
2. That's 1 times 2.
Whenever you change the front by, you do the opposite to the back.
Oh, negative 2.
There it is. Everybody understand? Remember we talked about balancing the scale. If you add and change the front by 2, you have to do the opposite from the back.
So you don't like multiply the 1 by the 2, it's just whatever's out in the front?
No. Good question. You do multiply the 1 by the 2. He admits to everybody.
So you multiply by the outside.
Yes. Whatever you put in here, multiply by the a value, and that's how much you change the front by. Do the opposite of the back. Yes?
So like, it wouldn't have been, if the 2 wasn't there, it wouldn't have been plus 1 again?
It wouldn't have. It would have been minus 1. Because however much, and I know I said this over and over, but it's because it's very true. However much you manipulate or change the front, you do the opposite to the back, okay? So now we're ready to rewrite it in vertex form. How would I rewrite this trinomial u?
X minus one.
Yeah.
Then plus 4. Oh, squared.
Thank you.
Plus 4.
Yes. That is vertex form, right? 100% ready in vertex form. Just a reminder, vertex form was a x minus h quantity squared plus k. The good thing about having vertex form is that we can now find our h and our k, our AOS, and we're going to get right into our domain and range. So, first up, vertex u.
1, 4.
Yes, because h is opposite, k is okay. Remember we learned that over and over. H is opposite, k is okay. Are we okay? Everybody with me here? AOS. You better say it right. U. Beautiful. X equals 1. It is not a number, it is a line. So we need the equation of a line. Domain. Don't you dare get punched. U. Excellent. I'm glad you sounded really excited about it. That's a long U. Range. Okay, range is the tough one. Before you do range, you got to know if it opens up or down. U, up or down.
Up.
Why?
Because the number in front of the equation, I guess.
Which is referred to as
A.
Uh-huh.
It's positive.
A is positive. You want to see something really cheesy? If A is positive, if someone's a positive person, they smile.
Oh, man.
Wait for it. If they're a negative person, you know what they do? They're grumpy.
Why didn't you say frown?
I want grumpy. Fine. If they're negative, they frown.
Oh, is it grumpy?
Grumpy.
Yeah,
Huh?
yeah, grumpy and
Grumpy.
smile.
Better.
Just saying.
The point still stands.
It's getting
If
funny.
it's positive, it opens up so it looks like a smile. It's negative, they're a negative person, they're grumpy, so they frown. Nailed it.
See, if you would have said that, then that would have been okay. But you just said because they're grumpy.
Any other worthless suggestions? Too mean? Dang it. Okay, so range. So we know we're opening up. We know we're opening up. So what's my range?
You put a bracket and then a 4, and then infinity with a parenthesis.
Nailed it. Everybody doing okay? Fist of 5, real quick. Nice. Okay. Time to graph. Time to graph. If I want to graph, I need to make a table. What goes in my table? U.
It'll be 3. No, it'll be 0 and then -1.
You can put 0, -1. What else could we have put?
2 or 3.
2 or 3. Everybody good? Either 2 up or 2 down from our AOS. All right, evaluation time. You can plug it back into the original or the vertex. I like the vertex because I'm proud of what we did. U. I need your help. We're going to plug 0 in. You ready? 0 minus 1. Squared times 2 plus 4. Nailed it. Order of operations, right? Follow with it. U. I need help on the next one. We're going to plug -1 in. -1 minus 1. -2 squared times 2 plus 4. Got a big one here. All right, I have everything I need. If you can get here, you're ready to graph, and you don't need anything else. Let's take a look at a quick graph. Pretty cool. All right. So I know I have a vertex of 1, 4. Remember, we usually do a dotted line so we can see where we're going to be mirroring. But be careful, that could be confusing later. We'll talk about it. Plot your points. Plot your points. 0, 6. And -1, we'll just guesstimate. About right there. I thought this was supposed to look like a parabola. Q? What can I use that for? Mirrored. Let's do it. So if this is 1 to the left, I have to go 1 to the right. I swear they said it, you just couldn't hear. Yes, 1 to the right. People watching this video are like, you did not teach this class well. All right.
Did we see the screener?
Yeah.
Okay.
So this is 2 to the left, we go.
To the right.
That was a scream. Okay, so
I didn't actually want to screener.
I was waiting for you to just holler.
No.
Okay, so normally we draw our curve. Normally we draw our curve. Why not here? Why not here? Someone new, someone new. Yes, you.
It's an inequality.
It's an inequality, which means I have to look at what?
If it's equal to.
Equal to or not, to tell me if it's,
Dotted or solid.
okay, so ours, is it equal to?
No,
So it is.
dotted.
All right, so I'm going to get rid of that just so I'm not confused later. Am I done? You, what do I have to do? Shading. Because the shading will represent all the points that make our inequality true. So there's infinite answers here. How do I know where to shade?
Yeah, you just.
You pick a point that's not.
Pick a point. It's not, well, keep,
That's not part of the parabola.
you pick a point not on the parabola, because it has to be decisively in or decisively out.
Thank you. 0, 0.
Everybody see 0, 0 is 100% what?
Out.
Out. So I'm going to test 0, 0 on my inequality. That's my x value, that's my y value. So I'm going to make it 0 less than 2, 0 minus 1 squared
We already did this.
plus 4. Agreed. We kind of know where we're going with this, but let's just make sure we get to the final true or false statement. Because we already plugged in 0, didn't we? Everybody realize that? We already plugged in 0 and we know it's going to become 6. If you don't believe me, do it. I'm right. Okay, so this does become 6. Is that a true statement?
Yes.
Okay, so I picked a point on the outside, and the outside was true, so where do I shade?
Outside.
Bingo. If it was false, where would I have shaded?
Inside.
Questions on 49.
So you shade opposite. You shade opposite of the point that you pick if it's false.
Yes.
But you shade the same side if it's true.
Summarized beautifully. Marker drop.